98.7% of your ancestors died in a single generation 930,000 years ago. Not metaphorically, not approximately. Exactly 98.7% of the human population was wiped out, leaving only 1,000 to 180 breeding individuals alive on the entire planet. In the next 80 minutes, you'll discover exactly how these 1,000 to 180 humans survived an extinction event that killed everyone else, and why their survival changed your DNA forever. The genetic bottleneck they endured is still affecting your immune system, your fertility, and your susceptibility to certain diseases right now in your body as you watch this. And what scientists found hidden in your chromosomes reveals a mystery so profound. It's rewriting everything we thought we knew about human evolution. Let me be clear about what we're talking about here. This wasn't a gradual decline. This wasn't a slow population drift over millennia. According to Dr. Wengji, whose groundbreaking 2023 study published in Science, the human population crashed from approximately 100,000 individuals to just 1,000 to 180 breeding pairs in what appears to be a single generation. That's a 98.7% mortality rate. To put that in perspective, if this happened today to our current global population of 8 billion people, only 100 per million would survive. Imagine every person in the United States, Mexico, and Canada, and that's it. Everyone else gone. But here's where it gets truly terrifying. This bottleneck didn't last a few years or even a few decades. It lasted 117,000 years. 117,000 years. Modern Homo sapiens have only existed for about 300,000 years total. This bottleneck lasted for more than 1/3 of our entire species' existence. Your ancestors survived 117,000 years with a breeding population smaller than a modern town, constantly on the edge of extinction. One bad winter away from humanity winking out of existence entirely. Every human alive today, all 8 billion of us, descend from those 1,000 to 180 survivors. Every single person. The person sitting next to you on the train. The celebrity you follow on social media. The world leader you saw on the news. Your family. Your friends. Your enemies. All of us carry the genetic signature of the most catastrophic near-extinction event. In human history, Dr. Giorgio Manzi from Sapienza University in Rome calls it the most extreme bottleneck in human evolutionary history, and he's spent his career studying hominin populations. This makes every other population crisis in human history look trivial by comparison. The event happened in Africa during the early Pleistocene Transition, a period when Earth's climate system was fundamentally changing in ways that would reshape the entire planet. But here's what keeps scientists awake at night. We have almost no fossils from this period. None. It's as if 117,000 years of human existence was simply erased from the archaeological record. Researchers call this the fossil gap, and it's one of the most frustrating mysteries in paleoanthropology. We find Homo erectus fossils before this period. We find Homo heidelbergensis fossils after this period. But during those critical 117,000 years, nothing but silence. Your genome contains scar tissue from this near-extinction event. When geneticists analyzed 3,150 for modern human genomes from across the globe, they found something remarkable. We're all incredibly similar to each other. You share 99.9% of your DNA with every other human on Earth. That sounds like a nice sentiment about human unity, but it's actually evidence of catastrophe. Chimpanzees, our closest living relatives, have far more genetic diversity than we do, even though there are fewer of them. Two chimps in the same forest can be more genetically different from each other than you are, from someone living on the opposite side of the planet. The reason their population never crashed to 1,280 individuals. They never went through a genetic bottleneck that eliminated 98.7% of their diversity in a single catastrophic event. Your mitochondrial DNA, the genetic material you inherit exclusively from your mother, passed through this bottleneck unchanged. Every single maternal ancestor you have, stretching back 930,000 years, survived this event. Think about that for a moment. An unbroken chain of mothers, each one managing to survive long enough to have a daughter who survived long enough to have a daughter. Through 117,000 years of the worst conditions humans have ever faced, the odds of your existence, mathematically speaking, are so close to zero that you shouldn't be here. But here you are. Doctor Who's team used a sophisticated algorithm called FitCall to detect this bottleneck. The algorithm analyzes mutation patterns in modern genomes and traces them backward through time. Using something called coalescence theory, every mutation in your DNA acts like a timestamp, allowing scientists to calculate when your ancestors' lineages split from each other. When they ran this analysis on thousands of genomes from every continent, all the data pointed to the same horrifying conclusion. 930,000 years ago, humanity nearly died out completely. But here's what makes scientists lose sleep at night. We have no fossils from this period. None. It's as if 117,000 years of human history were erased from the archaeological record. Except for one place, a handful of coastal sites in southern Africa that show continuous human occupation. Through this period, sites where people lived, made tools, ate shellfish, and somehow endured when the rest of the world became a graveyard. The question that haunts researchers: what was so special about these places? What did the 1,280 survivors know that the 98.7% who died did not? Scientists call it the ghost lineage period. From 930,000 to 813,000 years ago, humans existed, but they left almost no trace in the fossil record. It's as if our ancestors became ghosts, surviving somewhere, somehow, but invisible to the archaeological evidence that paleontologists depend on. This isn't just frustrating for researchers trying to understand human evolution. It's terrifying, because something happened during those years that was so catastrophic. It nearly erased us from existence. To understand how we know about this bottleneck despite the lack of fossils, you need to understand how modern genomics works. Your DNA is essentially a history book, and every letter in that book contains information about your ancestors. When Dr. Wang Jihu and his team at the Beijing Institute of Genomics analyzed 3,150 for human genomes from populations across Africa, Europe, Asia, and the Americas, they were looking for patterns in genetic diversity. Specifically, they were looking for places where that diversity suddenly collapsed. The Fit-Cole algorithm works by examining something called coalescent events. Imagine tracing your family tree backward through time. Eventually, your maternal line and your paternal line each converge on single individuals, one mother, one father who lived at specific points in history. Now imagine doing this for every human alive today, tracing millions of lineages backward through time. Coalescence theory tells us that all those lineages should spread out fairly evenly through history. But Doctor Who's team found something shocking. Between 930,000 and 813,000 years ago, almost all human lineages converge on an incredibly small population. Only 1,000 to 180 breeding pairs. This explains something that had puzzled paleontologists for decades: the fossil gap. We have numerous Homo erectus fossils from before 930,000 years ago. We have Homo heidelbergensis fossils from after 813,000 years ago. But during those critical 117,000 years, almost nothing. The few fragments we do have are so rare and fragmentary that they're barely useful for understanding what was happening to human populations. The genomic data solved the mystery. There weren't many fossils because there weren't many humans. The population was so small, scattered, and struggling that the chances of any individual fossilizing were vanishingly small. Your genome is remarkably uniform compared to other great apes. This isn't a good thing. Genetic diversity is nature's insurance policy against catastrophe. When a new disease emerges, or the climate changes dramatically, or food sources disappear, populations with high genetic diversity have a better chance that someone, somewhere, has the genetic variant that allows survival. But when 98.7% of your population dies, you lose 98.7% of your genetic diversity with them. All those unique gene variants, all those different ways of being human, all those potential adaptations to future challenges, gone, lost forever in a single generation. Dr. Giorgio Manzi at Sapienza University has spent years trying to understand the fossil gap. His research on hominin populations across Africa shows that before the bottleneck, humans were relatively widespread across the continent. Archaeological sites from this period are found from the Mediterranean coast in the north to the Cape of Good Hope in the south. From the Atlantic Ocean to the Indian Ocean, stone tools, evidence of butchered animals, signs of fire use all the markers of human presence was scattered across Africa. And then, suddenly, they almost completely disappear. For 117,000 years, the archaeological record goes nearly silent. The 2023 Science Journal publication that revealed these findings sent shockwaves through the scientific community. Some researchers initially questioned the methodology. Could the Fit-Cole algorithm be wrong? Could there be some other explanation for the genetic patterns? But as other teams replicated the analysis using different methods and different datasets, the same picture emerged. Around 930,000 years ago, something catastrophic happened to humanity. Something that brought us to the very edge of extinction. You're more genetically similar to someone living in Tokyo, Lagos, or Sao Paulo than to chimpanzees living in the same forest are to each other. That's a staggering fact. Chimps never went through a population bottleneck this severe. Neither did gorillas or orangutans. Only humans, only us. This bottleneck is why modern humans, despite living on every continent and in every climate zone, are remarkably similar to each other genetically. We're all cousins, separated by only a few hundred generations, all descended from the same tiny group of survivors. But when scientists looked at where this happened, they found something that seemed impossible. The climate data from this period showed environmental conditions that no human population should have been able to survive. Conditions that were so extreme, so hostile to life, that the real question wasn't why did 98.7% die. The real question was, how did any survive at all? The Earth was trying to kill us, not metaphorically, not indirectly through gradual changes, but actively and systematically making the planet inhospitable to human life. Between 950,000 and 850,000 years ago, Earth's climate system underwent a fundamental transformation called the Early-Middle Pleistocene Transition, and it was one of the most dramatic climate shifts in the last several million years. To understand why 98.7% of humanity died, you need to understand what this transition did to Africa, the continent where all humans lived at the time. Before this transition, Earth's ice age cycles followed a relatively predictable 41,000-year pattern, controlled by the tilt of Earth's axis. These cycles brought cold periods and warm periods, but they were manageable. Species adapted, ecosystems shifted but survived. Life found a way. But around 950,000 years ago, something changed in Earth's climate system. The Ice Age cycles suddenly shifted to a 100,000-year pattern, and these new cycles were far more extreme. The cold periods got colder, the glaciers grew larger, and most critically for our African ancestors, the dry periods got much drier. Dr. Peter Domenical at Columbia University has spent decades studying African climate using marine sediment cores drilled from the ocean floor off Africa's coast. These cores contain layers of dust, pollen, and microscopic organisms that act like a climate history book, recording environmental conditions year by year, century by century, millennium by millennium. What Dr. Domenical's team found in the layers corresponding to our bottleneck period was terrifying. Massive dust deposition indicating mega-droughts unlike anything in modern human experience. The Sahara Desert, already large, expanded dramatically, but it wasn't just the Sahara. Forests across sub-Saharan Africa turned into grasslands. Grasslands turned into scrublands. Scrublands turned into deserts. Lakes dried up. Rivers stopped flowing or dwindled to seasonal trickles. The reliable water sources that humans and animals depended on simply disappeared. Dr. Rick Potts at the Smithsonian's Human Origins program describes this period as environmental chaos, rapid oscillations between wet and dry that prevented any stable adaptation. Just when populations adapted to dry conditions, wet periods would return. Just when they adapted to wet conditions, devastating droughts would strike again. Your body's ability to enter ketosis during starvation to burn fat for energy when food disappears was refined and intensified during this period. This metabolic flexibility isn't something all primates have to the same degree. It's a survival adaptation that was quite literally burned into your DNA by ancestors who went days, sometimes weeks, without reliable food. When your body starts burning fat during a fast or a low-carb diet, you're experiencing an echo of the desperate hunger that 1,000 to 180 humans endured for 117,000 years. The 2019 paleoceanography studies paint a picture of an African continent that was hostile to life in ways modern humans have never experienced. Imagine the entire eastern half of the continent, from Ethiopia to South Africa, experiencing simultaneous mega-drought. Water holes that had existed for hundreds of thousands of years drying up completely. The megafauna that humans depended on for food: giant buffalo, ancient elephants, massive antelopes dying in huge numbers or migrating away to regions humans couldn't follow. The plants that provided backup calories when hunting failed: tubers, fruits, nuts, seeds withering and disappearing. The archaeological evidence from this period, sparse as it is, tells a grim story. The few sites that show human occupation reveal something disturbing. Increased evidence of resource stress. Stone tools show signs of being used for longer periods before being discarded, suggesting raw materials for making new tools was scarce. Animal bones show evidence of more complete processing, every scrap of meat removed, every bit of marrow extracted. Bones sometimes burned as fuel when wood became scarce. These are the signatures of populations in desperate survival mode. Competition for dwindling resources almost certainly turned lethal. When Dr. Curtis Marine at Arizona State University examined hominin bones from sites dating to this period, he found something that makes the horror even more visceral: cut marks. The same butchery patterns used to process animal meat appear on human bones. Our ancestors, pushed to the absolute edge of survival, sometimes resorted to the ultimate taboo, not because they were savage or evil, but because they were starving and desperate, and trying to survive in a world that was actively trying to kill them. And then, scientists discovered something in the archaeological record that made the mystery even darker. Despite all this catastrophe, despite the mega-droughts and the starvation and the die-offs, there were places where humans continued to survive. Coastal sites in southern Africa, caves along the Mediterranean, a handful of scattered refuges where the evidence suggests continuous human occupation. Right through the worst of the bottleneck period. These weren't large populations, we're talking about small groups, maybe a few dozen individuals per site. But they survived when 98.7% of humanity was dying. The question that haunts researchers: what did these survivors have that everyone else didn't? What was different about these places? What knowledge or adaptation allowed 1,000 to 180 humans to endure 117,000 years of environmental hell that killed hundreds of thousands of their relatives? The survivors weren't stronger. They weren't faster. Archaeological evidence suggests early humans were actually becoming slightly smaller during this period, probably due to nutritional stress. What the 1,000 to 180 survivors had was something more valuable than physical prowess: cognitive flexibility, the ability to eat almost anything, live almost anywhere, and adapt almost instantly to changing conditions. Your ancestors weren't the most powerful predators on the African continent. They were the most adaptable. Dr. Curtis Marian's research at Pinnacle Point in South Africa has revolutionized our understanding of how humans survived the bottleneck. Pinnacle Point is a series of caves along the southern coast of South Africa, and the archaeological layers from the bottleneck period show something remarkable. Continuous human occupation through the worst of the climate crisis. While the interior of Africa was turning into a dust bowl, these coastal caves provided a refuge. But not just any refuge or buffet. The ocean doesn't care about terrestrial droughts. When rivers dried up and grasslands turned to desert, the ocean's productivity continued. Shellfish, the rocky intertidal zones along the coast, became humanity's salvation. The caves at Pinnacle Point contain layer after layer of discarded shells, mussels, limpets, whelks, barnacles, evidence that humans were intensively exploiting marine resources. This wasn't occasional coastal foraging. This was a complete dietary shift, a fundamental change in how humans obtained calories. But here's the fascinating part. Harvesting shellfish requires knowledge. You need to understand tides, because shellfish beds are only accessible at low tide. You need to understand seasons, because some species are toxic during certain months. You need to have tools to pry limpets off rocks before they clamp down. You need to know which species are safe to eat and which will kill you. This knowledge represents cognitive sophistication, cultural transmission, careful observation of natural patterns. The 1,000 to 180 survivors weren't just physically surviving. They were thinking their way through the crisis. The stone tools from this period show increased sophistication compared to earlier times. Before the bottleneck, Homo erectus made relatively simple tools: hand axes, crude scrapers, basic choppers. During the bottleneck, we see evidence of more complex tool-making techniques. Blades struck from prepared cores, composite tools with multiple parts fitted together, specialized tools for specific tasks. Some researchers believe this technological leap wasn't coincidental, it was driven by necessity. When your survival depends on efficiently processing every possible food source, tool innovation becomes a matter of life and death. Your ability to digest an incredibly wide range of foods, from raw vegetables to cooked meat to fermented fish to insect larvae to bone marrow to bitter tubers, is unusual among primates. Most primates are specialists. Gorillas eat mostly leaves. Chimpanzees eat mostly fruit and occasional meat. Orangutans eat mostly fruit. But humans? We eat everything. We're the ultimate omnivores, capable of extracting calories from an absurd range of sources. This wasn't always true. This dietary flexibility intensified during the bottleneck, when populations that were too specialized died out and populations that could eat anything survived. Evidence from Wonderwork Cave in South Africa, dated to around 800,000 years ago near the end of the bottleneck period, shows something revolutionary: controlled use of fire. Not just occasional use, not just opportunistic use of natural fires, but deliberate, controlled fire making and fire maintenance inside a cave. This changes everything. Fire transforms inedible plants into edible calories. Fire breaks down toxic compounds in roots and tubers. Fire allows you to digest nutrients from meat more efficiently. Fire extends your foraging range because you can cook and store food. Fire is the difference between barely surviving and beginning to thrive. Dr. Richard Wrangham at Harvard has argued that cooking was one of the most important innovations in human evolution. His research suggests that the ability to cook food provided so many caloric benefits that it drove increases in brain size and decreases in gut size. Bigger brains require more calories. Cooking provides more calories from the same amount of food. This creates a positive feedback loop. Better fire control allows more cooking. More cooking provides more calories. More calories allows bigger brains. Bigger brains allow better fire control. The 1,000 to 180 survivors who made it through the bottleneck were right at the center of this revolutionary transition. But survival came at a terrible cost. The genomic evidence is clear. Genetic diversity collapsed. Rare gene variants were lost. Potential adaptations to future challenges disappeared from the human genome. The survivors weren't necessarily the best of humanity, they were just the luckiest. The ones who happened to be in the right place when catastrophes struck. They might have been coastal populations who already knew how to exploit marine resources. They might have been groups living near perennial springs that never dried up, even during the worst droughts. They might simply have been populations small enough and isolated enough to avoid the diseases that swept through larger, more connected populations. The cut marks on hominin bones from this period suggest another grim reality. Violence between groups probably intensified as resources dwindled. Competition wasn't just between humans and the environment, it was between humans and other humans. When water holes dry up and herds disappear, the group that controls the last reliable food source survives, and the groups that don't die. Some researchers speculate that this period of intense competition may have selected for increased social cohesion within groups. Cooperation became survival. Trust became essential. The ability to work together, share resources, and maintain social bonds under extreme stress became the difference between life and death. But that's not the full story. Because when geneticists looked closer at the 1,000 to 180 survivors, they found something that should be impossible. Something that contradicts everything we know about population bottlenecks. The survivors maintained genetic diversity that shouldn't exist. And that paradox holds the key to understanding how they survived. Here's the problem. 1,000 to 180 breeding individuals should create genetic catastrophe. That's a tiny population. For comparison, most conservation biologists consider any species with fewer than 5,000 individuals to be critically endangered, at severe risk of inbreeding depression, genetic drift, and extinction. Cheetahs went through a population bottleneck about 12,000 years ago. That left them with low genetic diversity, and they still suffer from it today: high infant mortality, poor disease resistance, fertility problems. The 1,000 to 180 humans who survived our bottleneck faced the same threat. But somehow, we're okay. Better than okay. We went from 1,000 to 180 individuals to 8 billion in just 930,000 years. How the answer lies in something called population structure. When Dr. Sarah Tishkoff's team at the University of Pennsylvania analyzed African genetic diversity in detail, they discovered something crucial. The 1,000 to 180 survivors weren't one unified population. They were scattered pockets of humans, isolated from each other by geographical barriers, mountain ranges, deserts, rivers, forests, but occasionally in contact. This structure prevented the worst effects of inbreeding while maintaining enough gene flow to preserve diversity. Imagine Africa 900,000 years ago as an archipelago of habitability in an ocean of hostility. Here, a group of 200 humans living along a coastal refuge in South Africa. There, a group of 150 humans clustered around a permanent spring in the East African Rift Valley. Over there, a group of 100 humans in caves along the Mediterranean coast. Each group isolated most of the time, maintaining their own cultural practices, adapting to their specific environment. But occasionally, maybe once every few generations, members of different groups would meet. Perhaps during a rare good year, when water was abundant and travel was possible. Perhaps when one group was forced to migrate by local conditions. These rare mixing events prevented inbreeding disaster while keeping populations distinct enough to maintain adaptive variation. Your immune system genes, particularly the human leukocyte antigen HLA complex, show something remarkable. Despite the bottleneck, HLA genes have extremely high diversity compared to the rest of your genome. This isn't random. This is evidence that the bottleneck, severe as it was, preserved disease-fighting genetic variants because populations without them died out completely. The groups that survived were the ones that maintained enough immune diversity to fight off the diseases that proliferated when populations were stressed, malnourished, and living in close quarters in caves and coastal refuges. Dr. Brenner Henn's population structure studies, published in Cell Journal in 2021, reveal fascinating patterns in African genetic diversity. Some variants common in West Africa are rare in East Africa. Some variants common in Southern Africa are absent in Northern Africa. This mosaic of genetic diversity is the signature of populations that were separated for long periods, but never completely isolated. The 1,000 to 180 survivors weren't a single tribe huddled in one cave. They were a network of scattered populations, each adapting to their local conditions, each maintaining their piece of humanity's genetic puzzle. But this raises even more questions. How did these isolated populations maintain contact across hundreds or thousands of kilometers? What motivated individuals to undertake dangerous journeys between refuges? How did they communicate across linguistic barriers that must have developed during long periods of isolation? The archaeological evidence is frustratingly silent on these questions. We can see that gene flow occurred, the genetic data proves it, but we don't know how or why. Some researchers speculate that resource abundance in good years triggered population expansions and migrations. When a rare wet period returned, populations would grow and spread out from their refuges, occasionally encountering other groups, before the next drought forced everyone back to their respective havens. These expansion-contraction cycles, repeated hundreds of times over 117,000 years, could have maintained genetic connectivity while keeping populations mostly isolated. Others suggest that cultural mechanisms maintained contact, perhaps the ancestors of trade networks, with groups exchanging tools, raw materials, or even marriage partners during rare peaceful encounters, perhaps shared rituals or gathering places where multiple groups would converge. During specific seasons, perhaps even early forms of diplomacy, where groups that controlled critical resources would allow controlled access to neighbors in exchange for other goods or services. We're speculating here because the archaeological evidence is so sparse. But the genetic evidence proves that somehow, despite catastrophic population collapse, despite mega-droughts and starvation and violence, humanity maintained just enough connection to survive. The 2021 Cell publication analyzed thousands of African genomes and found something else. Evidence of ancient population structure that persisted through the bottleneck and still shapes modern African genetic diversity. If you drew a genetic map of Africa today, you'd see patterns that were established during the bottleneck period. These aren't just neutral genetic differences, they represent different adaptive solutions to the same catastrophic pressure. West African populations, East African populations, and Southern African populations each found their own path through the crisis. And those paths shaped their genomes in ways that persist nearly 1 million years later. If you're using this to fall asleep, that's perfect. That's exactly why I make these. The rhythm of these words, the flow of this information, is designed to carry you peacefully into rest, while your unconscious mind processes the profound reality that you're descended from survivors. Let me know in the comments where you're listening from. And then, 813,000 years ago, something changed. The population exploded. From 1,000 to 180 breeding pairs to tens of thousands in just a few generations. From scattered refuges to widespread occupation of Africa. From barely surviving to beginning to thrive. The genetic data shows this population boom clearly sudden expansion in lineage diversity. Rapid increase in archaeological sites, evidence of technological innovation accelerating. The question that haunts scientists: why? What changed? What ended the bottleneck and allowed humanity not just to survive, but to flourish? Climate records from ocean sediment cores and ancient lake beds show something remarkable happened. Around 815,000 years ago, the rain returned. Not permanently, not everywhere, but in a pattern that was just stable enough, just predictable enough, to allow human populations to expand from their coastal and spring-fed refuges back into the African interior, the African humid period that began at the end of the bottleneck. Transformed deserts back into grasslands, dried lake beds back into thriving wetlands, and gave life a second chance. Dr. Peter Domenical's climate research shows that monsoon patterns shifted, bringing seasonal rains back to regions that had been arid for over 100,000 years. This wasn't a sudden switch from desert to paradise. Climate patterns during this time remained variable and unpredictable, but it was enough. Enough for grasses to return. Enough for animal herds to migrate back into regions they'd abandoned. enough for humans to cautiously, carefully begin expanding from their refuges into territories that had been death zones for thousands of generations. The archaeological evidence shows a sudden increase in site density and tool diversity right at the end of the bottleneck period. Sites that had been continuously occupied for millennia suddenly show signs of population growth, more tool debris, more food waste, more evidence of daily activities. New sites appear in regions where humans hadn't lived for 100,000 years. The survivors were expanding, spreading out, reclaiming the continent their ancestors had once occupied. But they weren't the same humans who had gone into the bottleneck. They had changed. The control of fire became widespread during this period. Evidence from Wonderwork Cave and other sites dated to around 800,000 years ago shows deliberate, repeated, controlled fire use in cave contexts. This is revolutionary. Dr. Francesco Berna's 2012 PNAS study identified microscopic evidence of controlled burning ash, layers, burned bone fragments, charcoal from specific wood types that humans would have selected and carried into caves. This isn't opportunistic use of wildfires. This is human-made fire, human-controlled fire. Fire as a tool as important as any stone implement. Fire changes everything. Fire extends the day, allowing humans to work and socialize after dark. Fire provides warmth, allowing humans to live in colder regions and higher elevations. Fire protects against predators, cave bears, leopards, hyenas. The ancient predators that competed with humans for cave shelter would avoid fire. Fire processes food, making previously inedible plants safe and digestible, extracting more calories from meat, rendering bones soft enough to access marrow. Fire creates a focal point for social gathering, strengthening group bonds, facilitating cultural transmission, allowing elders to teach young ones in the firelight. Your ability to digest cooked starches is directly linked to this period. The AMY1 gene produces salivary amylase, an enzyme that breaks down cooked starches in your mouth. Modern humans have multiple copies of this gene, between 2 and 15 copies, depending on your ancestry. And the number of copies correlates with how much your ancestors relied on cooked starchy foods. The gene amplification that gives you this ability accelerated during and after the bottleneck period, when fire cooking became not just a convenience, but a survival necessity. Dr. Richard Wrangham's cooking hypothesis proposes that regular access to cooked food provided so many benefits that it drove the evolution of smaller guts and larger brains. Raw food requires a large, energy-intensive digestive system to process. Cooked food is pre-digested by heat, requiring less gut tissue to extract nutrients, freeing up energy for other purposes like feeding an energy-hungry brain. The transition from Homo erectus to Homo heidelbergensis that happened during the bottleneck period involved exactly this trade-off: smaller teeth and jaws, reduced gut size, increased brain volume. The 1,000 to 180 survivors and their immediate descendants were the first humans to fully commit to fire as essential technology. And this commitment transformed their bodies. But climate improvement and fire control alone don't fully explain the population explosion. There's something else in the genetic record, something subtle but profound. The survivors who emerged from the bottleneck showed increased genetic markers associated with cognitive flexibility, social cooperation, and behavioral adaptability. The bottleneck didn't just reduce human genetic diversity, it selected for specific traits. The populations that survived were the ones that could cooperate under stress, adapt to changing conditions, innovate solutions to novel problems, and maintain social cohesion when every instinct said to fracture into competing factions. Your ability to cooperate with strangers, to form large social groups with complex hierarchies, to maintain friendships and alliances across distance and time. These sophisticated social behaviors were intensified during the bottleneck. Populations that couldn't maintain social cohesion under extreme stress fractured and died. Populations that could cooperate, share resources, divide labor, and maintain trust survived. You carry the genes of humans who chose cooperation over competition when it mattered most. The 2012 fire evidence from Wonderwork Cave shows something else. The burning was concentrated in specific areas of the cave, suggesting designated hearths, maintained repeatedly over time. This is social organization. This is planning. This is a group of humans who weren't just surviving day to day, but organizing their living space, creating something like a home. The transition from desperate survival to intentional living happened somewhere in the late bottleneck period, and it made all the difference. Archaeological sites from the post-bottleneck period show evidence of long-distance raw material movement. Obsidian from volcanic sources transported hundreds of kilometers to coastal sites. High-quality stone tool materials moved between regions. This is evidence of something like trade networks, or at least of humans traveling much longer distances than they had during the peak crisis. The refuges that had isolated survivors during the worst of the drought were now connected by expansion populations moving through reopened territories. But why does this matter for you, someone living 930,000 years later? Someone who has never experienced mega-drought or population bottleneck, or desperate survival at the edge of extinction? Because the genetic changes from this bottleneck are still shaping your life, your health, your capabilities and limitations in ways you've never imagined. The 1,000 to 180 survivors left you a legacy, and that legacy is written in every cell of your body. Let's talk about your body, not ancient humans, not archaeological sites, not genetic abstractions. You, the person listening to this right now. The bottleneck that nearly killed humanity 930,000 years ago is still affecting your daily life. In tangible, measurable ways. Your reduced genetic diversity makes autoimmune diseases more common in humans than in other primates. When a population crashes to 1,000 to 180 individuals, rare genetic variants get lost. Some of those lost variants probably provided resistance to autoimmune conditions situations, where your immune system mistakenly attacks your own tissues. Rheumatoid arthritis, multiple sclerosis, type 1 diabetes, lupus, Crohn's disease. These conditions are remarkably common in humans, but rare in our closest primate relatives. Part of the reason is that our immune systems, genetically streamlined by the bottleneck, have less variety in how they distinguish self from foreign. Dr. Joshua Aki's research at Princeton on deleterious mutations shows that humans carry a higher burden of slightly harmful genetic variants than expected, many of which affect immune function. The bottleneck eliminated protective diversity we desperately needed. Your fertility challenges are partly a legacy of the bottleneck. Humans have surprisingly low conception rates compared to other mammals. If you're trying to conceive, you have roughly a 20% chance per ovulation cycle under ideal conditions. For chimpanzees, it's over 40%. For most other mammals, it's even higher. Why are humans so bad at making babies? Population genetics provides part of the answer. The bottleneck eliminated genetic variants that supported robust fertility, and the variants that remained are just functional enough, but not optimal. Studies published in Science Advances in 2020 show that humans carry more mutations in fertility-related genes than any other great ape species, many of which slightly reduce conception efficiency or increase early miscarriage rates. YOUR cancer susceptibility is influenced by bottleneck genetics. Tumor suppressor genes genetic systems that prevent cells from becoming cancerous show reduced diversity in humans compared to other primates. When the population crashed to 1,000 to 180 individuals, some protective variants of these genes were lost permanently. This doesn't mean the bottleneck caused cancer, but it means that the genetic toolkit your body uses to fight cancer formation is slightly less diverse, slightly less robust than it could have been if humanity had never gone through this near-extinction event. Your high infant mortality compared to other primates has genetic components traced to the bottleneck. Human babies are remarkably fragile, even with modern medicine. Roughly 1 in 30 pregnancies ends in stillbirth or neonatal death in developing countries. For mountain gorillas, a species with far fewer individuals than humans and their own genetic challenges, infant mortality is lower. The genetic uniformity created by the bottleneck means that when rare harmful mutations arise, they can spread through populations more easily because there's less genetic diversity to buffer their effects. Some genetic variants that would have been eliminated by natural selection in a larger population persisted after the bottleneck simply because they weren't fatal enough to prevent reproduction. In the desperate conditions survivors faced, and this is crucial, the bottleneck didn't just harm us. It also shaped our greatest strengths, your cognitive abilities, the problem-solving capacity that allowed humans to eventually dominate every ecosystem on Earth, were sharpened during the crisis. The survivors were selected not just for physical resilience, but for mental flexibility, the ability to learn from experience, to innovate solutions to novel problems, to cooperate with others under stress, to teach and learn complex skills. These cognitive traits were survival necessities during the bottleneck, and populations that lacked them died out. Dr. Svante Pääbo's groundbreaking genomic research at the Max Planck Institute has identified specific genetic changes that occurred during the bottleneck period. Genes involved in brain development show signatures of positive selection, meaning they changed faster than neutral drift would predict. Because individuals with certain variants survived better than individuals without them, The survivors weren't just lucky. They were, in a very real genetic sense, smarter and more adaptable than the populations that died. And you carry their intelligence in your genome. Why owe you our genetic similarity to all humans the 99.9% DNA identity you share with every person on Earth? Is a direct result of 1,000 to 180 survivors. We're all cousins, separated by just 930,000 years and roughly 30,000 generations. This genetic closeness has profound implications. It means that superficial differences between human populations' skin color, hair texture, facial features are exactly that, superficial. They're recent adaptations to local environments, written on top of a genetic foundation that's remarkably uniform. The person sitting next to you, regardless of their appearance or ancestry, is more closely related to you than you might think possible. This genetic similarity has both benefits and costs. The benefit: humans can cooperate across population boundaries more easily than species with high genetic diversity, because we're fundamentally not that different from each other. The cost: a disease that affects one human population has a good chance of affecting all human populations because our immune systems are so similar. The COVID-19 pandemic demonstrated this reality. A novel virus emerging in one city spread globally because every human immune system, shaped by the same bottleneck, responded to the threat in similar ways effectively for some, catastrophically for others. But predictably based on our shared genetic heritage, your ability to live anywhere on Earth, from Arctic tundra to tropical rainforest to high-altitude mountains to scorching deserts, comes from the adaptability that was forged during the bottleneck. Other primates are specialists. Gorillas live in specific forest types at specific elevations. Orangutans live only in specific tropical rainforests. Chimpanzees live in tropical forests and woodlands, but nowhere else. Humans, we live everywhere. Antarctica, the Sahara, the Amazon, the Himalayas, tiny Pacific islands. Arctic coastlines, there's almost nowhere on Earth humans haven't successfully colonized. This extreme adaptability, this ability to survive in any environment, was the trait that saved our ancestors 900,000 years ago and remains our species-defining characteristic. The 2020 science advances. Publication on deleterious mutations included a finding that stunned researchers. Despite the bottleneck, despite the loss of genetic diversity, humans show surprisingly robust DNA repair mechanisms. Your cells are constantly fixing errors in your DNA, preventing mutations that could cause cancer or genetic disease. These repair systems, encoded in your genome, work slightly better in humans than in other primates. The bottleneck may have selected for populations with particularly effective DNA repair, because in a small population, every individual matters. Populations that could maintain genetic integrity despite inbreeding and environmental stress survived. Populations that couldn't die out. Your genetic similarity to all humans on Earth means that when you look at another person, any person, anywhere you're looking at family, distant family, certainly, but family nonetheless. The person who delivers your mail, the celebrity on your screen, the political leader you disagree with, the stranger passing you on the street, all of them descended from the same 1,000 to 180 survivors. All of them carried genes that survived 117,000 years of hell. All of them are your cousins, products of the same catastrophic bottleneck that shaped your genome. There's one final piece to this story, something that changes everything we thought we knew about human uniqueness, about our place in the story of life on Earth, about what it means that 1,000 to 180 humans refused to go extinct, when every environmental indicator said they should. The bottleneck didn't just reduce human population numbers. It created a new species, not metaphorically, not approximately, but literally. The humans who went into the bottleneck as Homo erectus emerged from it transformed, changed, evolved. The 1,000 to 180 survivors and their descendants, shaped by 117,000 years of extreme selection pressure, became something that had never existed before. Homo heidelbergensis, the direct ancestor of Neanderthals, Denisovans, and modern humans. This is speciation in action. This is evolution operating at crisis speed, driven by environmental catastrophe and population collapse. Dr. Chris Stringer at the Natural History Museum in London has spent decades studying the fossil evidence for human evolution, and his research shows a clear pattern. Before the bottleneck, we see classic Homo erectus anatomy. After the bottleneck, we see Homo heidelbergensis anatomy: larger brains, different skull shapes, more sophisticated tools, evidence of more complex behavior. The transition happens during the ghost lineage period. During those 117,000 years when humans were too rare to fossilize much, when the population was so small that evolutionary changes could spread through the entire species. In just a few dozen generations, your species Homo sapiens exists because of this bottleneck. If the population hadn't crashed, if the climate hadn't turned catastrophic, if humans had remained numerous and widespread across Africa, we would probably still be Homo erectus. Stable populations in stable environments don't evolve rapidly. They don't need to. But populations on the edge of extinction, populations where every generation faces survival or death selection pressure, populations so small that beneficial mutations can spread quickly, those populations evolve fast. The survivors weren't just preserving humanity, they were transforming it. Every generation that survived the bottleneck was, by definition, better adapted to survival than the generation before. The ones who couldn't cooperate effectively died. The ones who couldn't innovate tool solutions died. The ones who couldn't digest diverse foods died. The ones who couldn't control fire died. The ones who couldn't maintain social bonds under stress died. What remained after 117,000 years of this relentless selection was a population profoundly different from their pre-bottleneck ancestors. Dr. Lee Berger's research on hominin species diversity shows something remarkable. The period immediately following the bottleneck saw an explosion of hominin forms. Homo heidelbergensis, emerging from Africa, spread into Europe and Asia, and then diversified. In Europe, they evolved into Neanderthals, adapted to Ice Age conditions and megafauna hunting. In Asia, they evolved into Denisovans, about whom we still know frustratingly little, but who clearly adapted to high-altitude environments and cold climates. In Africa, They eventually evolved into Homo sapiensis, the modern human form, with our unique skull shape and cognitive abilities and creative capacities, emerged from this post-bottleneck diversification. But here's the profound truth. All of these species, all of these different branches of humanity, descended from the same 1,000 to 180 survivors. Neanderthals, Denisovans, and modern humans are all children of the bottleneck. We're not separate evolutionary lineages that happened to coexist. We're sibling species, born from the same catastrophic event, shaped by the same desperate survival, carrying the same genetic legacy from ancestors who refused to go extinct. The 2023 Annual Review of Genomics and Human Genetics includes a stunning analysis of hominin diversification patterns. When researchers traced genetic lineages backward through Neanderthals, Denisovans, and modern humans, all three lines converge on a common ancestor population living around 800,000 years ago, exactly when the bottleneck ended. This isn't coincidental. This is the signature of a founding population, a small group of survivors whose descendants eventually split into separate species as they spread across different continents and adapted to different environments. Your ability to interbreed with Neanderthals, and you do carry Neanderthal DNA if you have any non-African ancestry, exists because the species split was recent and incomplete. You carry between 1% and 4% Neanderthal DNA in your genome, genes that flowed into your ancestors when they encountered Neanderthals in Europe and Asia between 50,000 and 60,000 years ago. But that interbreeding was only possible because Neanderthals and modern humans were closely related, separated by only about 500,000 years of independent evolution. The reason we were closely related, because we both descended from the post-bottleneck Homo heidelbergensis population that emerged 813,000 years ago. Without the bottleneck, modern humans might not exist. This is a difficult truth to absorb. The catastrophe that killed 98.7% of humanity created the conditions necessary for our species to emerge. The suffering, the starvation, the violence, the desperate survival, all of it, horrible as it was, drove evolutionary changes that made us possible. We're not here despite the bottleneck. We're here because of it. Your species emerged from catastrophe transformed. The cognitive abilities that allowed humans to eventually develop language, art, music, mathematics, science, civilization. All of these capabilities have their roots in adaptations forged during the bottleneck period. The 1,000 to 180 survivors didn't know they were creating a new species. They were just trying to live one more day, find one more meal, make it through one more drought. But their survival, their adaptations, their genetic changes accumulated over 117,000 years until they became something unprecedented in Earth's history, a species capable of transforming the entire planet. Dr. Stringer's research includes a sobering observation. Nearly every major transition in human evolution corresponds with environmental crisis. Walking upright emerged during a period of forest fragmentation in Africa. Stone tool use intensified during climate variability. Cooking and fire control spread during resource scarcity. and the transition from Homo erectus to Homo heidelbergensis, the ancestor of all modern humans, happened during the worst population crash in human history. Crisis, it seems, is the forge in which human evolution is shaped. The genetic evidence shows something else: the cognitive changes that occurred during the bottleneck involved not just brain size but brain organization. Genes controlling neural connectivity, synaptic plasticity, and information processing show signatures of selection during this period. Your brain isn't just bigger than a Homo erectus brain. It's wired differently, organized differently, capable of things that earlier humans simply couldn't do. The survivors needed every cognitive advantage they could get, and populations whose brains were slightly better at problem solving, pattern recognition, social coordination, and adaptive planning survived when others didn't. What does this mean for humanity? For our future? For the story we tell ourselves about who we are and where we came from? It means we're simultaneously more fragile and more resilient than we like to think. Fragile because we came within 1,000 to 180 individuals of extinction. Resilient because those 1,000 to 180 individuals survived 117,000 years of environmental hell and emerged transformed. It means that crisis can be creative as well as destructive. It means that the worst moments in our history sometimes become the seeds of our greatest transformations. Humans are simultaneously the most fragile and most resilient species that has ever existed. We nearly went extinct 930,000 years ago, down to 1,000 to 180 breeding pairs. One bad disease, one failed harvest, one unlucky drought season, and humanity winks out of existence. Gone forever. No second chances in evolution. When a species goes extinct, it's permanent. Those 1,000 to 180 survivors had no guarantee they would make it. Most species that reach such low numbers don't recover. They spiral into extinction, genetic diversity too low to adapt, population too small to survive random catastrophes. But we survived anyway. Against all odds, against all reasonable predictions, humanity clawed its way back from the edge. The 1,000 to 180 became 10,000. The 10,000 became 100,000. The 100,000 eventually became 8 billion. From the smallest bottleneck to the largest population of any large mammal on Earth, this recovery, this refusal to give up, this sheer stubborn determination to survive, it's written into your DNA, burned into your genetic code by ancestors who endured when ending would have been easier. Our uniformity is both a weakness and a strength. The weakness: we're all vulnerable to the same threats. A disease that can kill one human can potentially kill all humans. An environmental crisis that affects one population affects all populations. The low genetic diversity that resulted from the bottleneck means we don't have the built-in insurance policy that high diversity provides. The strength: we're all fundamentally the same. The racist ideologies that claim fundamental differences between human populations are scientifically nonsense. We're separated by at most 100,000 years of superficial adaptation to local environments, built on a foundation of 930,000 years of shared heritage. The person who looks nothing like you shares 99.9% of your DNA. Your family, The survivor's legacy is complex. We carry both trauma and triumph in equal measure. The trauma, genetic scars from the bottleneck that make us vulnerable to autoimmune diseases, fertility challenges, cancer susceptibility, and other health issues. The triumph, cognitive abilities, adaptability, and resilience that allowed us to eventually dominate every ecosystem on the planet. You carry both. Every human does. We're damaged and powerful, fragile and unstoppable, broken and beautiful. Current human population stands at about 8 billion individuals. From 1,000 to 180 to 8 billion in just 930,000 years. That's an increase of roughly 6.5 million times. We went from nearly extinct to everywhere, from coastal refuges to every continent except Antarctica, from fire-using hunter-gatherers to spacefaring civilization builders. The arc of that transformation is staggering. In evolutionary terms, it's essentially instantaneous. In human terms, it represents 30,000 generations of survival, adaptation, innovation, and growth. But here's the question that keeps researchers awake at night. Are we creating our own bottleneck? Climate change is transforming Earth's ecosystems at rates not seen. Since the Early-Middle Pleistocene Transition, sea levels are rising, droughts are intensifying, agricultural systems are stressed, biodiversity is collapsing. We've been through this before, 930,000 years ago, and it nearly killed us. The difference is that this time, we're causing it. We're the climate crisis. And unlike the 1,000 to 180 survivors who had no choice but to endure, we have choices. We can change course. We can adapt. We can cooperate across boundaries. We can use the intelligence that was forged in that ancient bottleneck to prevent a future one. Drop a comment and tell me which fact has surprised you most so far. Before you drift off, let me know where in the world you're watching from. I love seeing different time zones experiencing this story together. This shared human heritage connecting us across continents and cultures. Dr. E.O. Wilson, the great evolutionary biologist who passed away in 2021, spent his career studying biodiversity and extinction. His research on island biogeography showed that small populations on isolated islands are incredibly vulnerable to extinction from random events. The 1,000 to 180 human survivors were essentially living on isolated islands, coastal refuges, and scattered havens in an ocean of hostile environment. By all predictions, we should have died out. Small populations rarely recover from bottlenecks this severe, but we did. Wilson called humans the most adaptable species in Earth's history, and he was right. Our ancestors proved it by surviving the unsurvivable. The philosophical implications are profound. If we're all descended from 1,000 to 180 survivors, if we all carry genes that survived 117,000 years of environmental catastrophe, if we're all cousins separated by fewer generations than recorded history spans, then what does that mean for how we treat each other, for how we organize our societies, for how we think about human rights and dignity and worth? The person you disagree with, the person whose politics or religion or culture seems incomprehensible to you, shares 99.9% of your DNA. They're your cousin. Their ancestors survived the same bottleneck yours did. They carry the same legacy of resilience and adaptability and stubborn refusal to go extinct. Your existence is the ultimate proof that life finds a way. Against climate catastrophe, against starvation, against disease and violence and despair. Against odds so long that survival seemed impossible, life found a way. Not through strength or speed or power, but through adaptability, cooperation, intelligence, and sheer determination. The 1,000 to 180 survivors had every reason to give up. The world was actively trying to kill them. Food was scarce. Water was scarce. Safe places to live were scarce. Every day was a struggle. Every year was a catastrophe. Every generation faced the real possibility of being the last generation of humans to ever exist. But they didn't give up. They adapted. They cooperated. They innovated. They endured. And here you are, 930,000 years later, listening to their story, carrying their genes, living the life they made possible through their refusal to surrender to extinction. You're not just descended from survivors. You're descended from the most resilient, most adaptable, most determined survivors in human history. That legacy is yours. That strength is yours. That refusal to give up when everything seems hopeless, that's yours too. Written in your DNA by ancestors who proved that humans can survive anything. As you drift off tonight, consider this profound truth. You are the descendant of the toughest, smartest, most resilient humans who ever lived. The 1,000 to 180 survivors who made it through 117,000 years of environmental hell. The ones who figured out how to eat shellfish when land animals disappeared. The ones who mastered fire when warmth meant survival. The ones who cooperated when violence would have been easier. The ones who taught their children how to survive. When the world itself had become hostile to human life. You carry their genes. You carry their resilience. You carry their determination. And in the deepest sense, you are them, continuing their story 930,000 years later. There's something profound about an unbroken chain stretching back 930,000 years. An unbroken chain of survival, connecting you to those 1,000 to 180 ancestors who refused to let humanity die. Every single one of your ancestors, every single generation between then and now, survived long enough to have children. Not one break in the chain, not one failure to survive to reproductive age. Not one generation where the line ended. That's roughly 30,000 generations of continuous survival. Each one passing the torch to the next, each one saying through their actions, we will not be the generation where this ends. Every human alive today shares this story. All 8 billion of us. We're all survivors, all descended from the same small population that endured when 98.7% died. This truth should change how we see each other. The stranger across the world, speaking a language you don't understand, living a life you can't imagine, practicing customs that seem foreign to you, they're your cousin. Distant, certainly, but cousin nonetheless. Your common ancestors lived 930,000 years ago along African coasts and scattered refuges, eating shellfish and cooking over fires, looking up at stars and wondering if tomorrow would come, if the rains would return. if their children would survive to have children of their own. The mystery and majesty of deep time is almost impossible to truly comprehend. 930,000 years. If each generation is about 25 years, that's 37,000 to 100 generations separating you from the bottleneck. If you tried to count your ancestors back to that time, naming one ancestor per second, it would take you over 10 hours of continuous counting. Each one of those ancestors was a real person, with hopes and fears and struggles and joys, with a life as vivid and complex as yours. And every single one survived long enough to pass their genes forward, creating an unbroken chain that eventually led to you. The 1,000 to 180 survivors couldn't know what they were creating. They couldn't know that their descendants would number in the billions. They couldn't know that humans would eventually spread to every continent, adapt to every climate, build cities and civilizations, create art and music and mathematics and medicine, reach for the stars themselves. They were just trying to survive, trying to find food, trying to keep fires burning, trying to protect their children, trying to make it through one more day, one more drought, one more generation. But in doing so, in refusing to surrender to extinction, they made everything that came after possible. Hope and resilience are encoded in our DNA. But they're not magical properties. They're products of selection. The populations that maintained hope during the bottleneck, that believed tomorrow might be better even when today was horrific, that kept trying when giving up would have been easier, those are the populations that survived. The ones who gave up, who surrendered to despair, who stopped trying, their lines ended. You don't carry their genes. You carry the genes of people who never stopped trying, never stopped hoping, never stopped believing that survival was possible even when all evidence suggested otherwise. Gratitude seems like an inadequate response to 930,000 years of survival. But it's what we have. Gratitude for the ancestors who endured. Gratitude for the genetic legacy they left you. Gratitude for the resilience they forged in fire and hunger and desperation. Gratitude for their refusal to let the human story end when it so easily could have. Every breath you take, every thought you think, every moment of consciousness you experience is a gift from ancestors who survived when survival seemed impossible. The night sky the 1,000 to 180 survivors looked up at 930,000 years ago was the same sky you see tonight. The same stars, the same moon, the same vast darkness punctuated by distant lights. They didn't know what those lights were. They didn't know about planets or galaxies or the cosmic scale of existence. But they looked up anyway, and in looking up, they demonstrated something uniquely human: curiosity, wonder, the desire to understand the world beyond immediate survival needs. That curiosity, that wonder, that desire to know it survived the bottleneck. It's in you now. If you found this journey through deep time meaningful, consider subscribing for more stories that connect ancient worlds to your modern life. These narratives of human resilience, of survival against impossible odds, of transformation through catastrophe, they're not just history. They're your history. They're the story of how you came to be, of the legacy written in your DNA, of the unbroken chain connecting you to the first survivors. The fire that the 1,000 to 180 survivors kept burning through 117,000 years of darkness still burns. It burns in you, in your curiosity, in your resilience, in your ability to adapt and cooperate and survive, in your refusal to give up when things get difficult, in your capacity to hope when the future seems uncertain. That ancient fire, kept alive by ancestors whose names are lost to time, but whose genes persist in your body, continues in every human alive today. We are all firekeepers, all survivors, all children of the bottleneck. Rest well tonight, knowing you carry the legacy of the most extreme survivors in human history. The ones who endured 117,000 years of environmental catastrophe. The ones who maintained enough genetic diversity to create a species. The ones who cooperated when competition would have ended everything. The ones who innovated when innovation meant life or death. The ones who hoped when hope seemed foolish. The ones who survived so that you could exist. The night those 1,000 to 180 ancestors looked up at African stars 930,000 years ago, they couldn't know that their descendants would number in the billions, would spread across every continent, would reach for those same stars from space itself. But they survived anyway. They endured. They refused to let the human story end. And because they didn't give up, because they kept trying day after day, year after year, generation after generation, through 117,000 years that should have been impossible, you're here, alive, conscious, carrying their fire forward into an unknowable future. Good night.